Let us now move on to learning about the various functional areas in temporal lobe and insula. First, let us begin with the functional areas in temporal lobe. The main functional areas which are located here are the auditory areas, which are located on the superior surface of superior temporal gyrus. So, if you open up the lips of the posterior ramus of lateral sulcus, the superior surface of superior temporal gyrus, which is the auditory areas area, shows two sulci running ventrolaterally that will divide the area into three parts: an anteriorly located planum polare, the middle area known as anterior transverse temporal gyrus of Heschel, and the posterior area known as planum temporal. Now, the primary auditory cortex, or the area A1 or area number 41, is located in the anterior transverse temporal gyrus of Heschel, more medially. This has a binaural representation, that is, it receives auditory input from both the ears, and it has tonotopic arrangement, that is, the sound waves with lower frequency are represented anterolaterally and the sound waves with higher frequency are represented posteromedially. Surrounding this area 41, we have auditory association cortex, or A2 area, or area 42. This is the auditory association area receiving input from primary auditory cortex. The main input and output for this area will be, the input comes from medial geniculate body. We have studied this whole thing in detail in the video on auditory pathway, so you can refer back to that video. Through commissural fibers, it communicates with the contralateral primary and auditory association cortex. It also sends output to dorsolateral and ventrolateral prefrontal cortex, the dorsolateral area being involved in localizing the sound and ventrolateral area involved in identifying the source of the sound. And it also sends output to posterior part of the superior temporal gyrus, or area number 22, which is the higher association area for auditory pathway, which helps in understanding what is being heard. It sends in information to cingulate gyrus, parahippocampal gyrus, as well as to amygdala. So, as I said earlier, the third auditory area, which is located within the temporal lobe, is the higher association area, or area 22, which is located in the posterior part of the superior temporal gyrus. This forms a part of Wernicke's sensory speech area, which is needed for comprehending spoken speech, and lesion to this area results in sensory aphasia. We talk more in detail about this area when we are dealing with speech. In addition to auditory area, we also have on the superolateral surface superior, middle, and inferior temporal gyri. The inferior temporal gyrus, or area number 20, is the higher visual association area. The posterior part of the inferior temporal gyrus receives input from V4, which is the anterior part of the area number 19, and then it projects to anterior part of the inferior temporal gyrus, middle temporal gyrus, temporal pole, prefrontal cortex, and frontal eye field. The middle temporal gyrus, that is area 21, is a polysensory area which receives auditory, somatosensory, and visual inputs, so it acts as a polysensory association area. Lesion to this area will result in visuospatial difficulty, hemiagnosia, as well as sensory dysphasia. Now, the temporal pole, or area number 38, that will receive input from superior temporal gyrus, inferior temporal gyrus, insula, and prefrontal cortex, and its main output is to limbic areas. Functions is, it is involved in memory, hallucinations, and dreams. Stimulating this temporal pole will result in recalling the object seen, or music heard, or smell, or even the past experiences. Whenever there is epileptic focus located in the temporal pole, it always is associated with auditory or visual aura or hallucinations. Bilateral ablation of area 38 will result in permanent loss of memory of the past experiences. There are various areas recognized or involved in face recognition. So on the inferior surface, we have collateral sulcus and occipitotemporal sulcus dividing the area into three gyri: parahippocampal gyrus, medial and lateral occipitotemporal gyrus. Within the parahippocampal gyrus, we have rhinal sulcus separating the uncus. The middle temporal gyrus on the superolateral surface, that is area 21. Inferior temporal gyrus, that is area number 20, situated on the superolateral surface, as well as the lateral occipitotemporal gyrus, that is fusiform gyrus. Without lateralization, that is both right and left sides, they are involved in face recognition. In addition, the hippocampus and the perirhinal area is involved in identifying the familiar faces. Amygdala is involved in identifying the fearful faces. So these are the areas which are involved in recognizing the face. Now coming to effects of lesion to temporal lobe. There is temporal lobe epilepsy, which is associated with olfactory, taste or auditory hallucinations. The epilepsy may be partial or generalized seizures. It will be associated with condition known as déjà vu or jamais vu. Déjà vu is a sense of having been in this experience before. Jamais vu is a sense of not being there in this experience before, although that person is familiar with those surroundings, he feels it is new. And temporal lobe epilepsy is even associated with lip smacking and chewing movements. So if an epilepsy, partial or generalized seizure associated with olfactory or taste or auditory aura, most likely it is temporal lobe epilepsy. Second condition is prosopagnosia. This is because of the involvement of inferior temporal gyrus as well as occipitotemporal gyrus, especially the lateral occipitotemporal gyrus. So here the patient has a problem that he is unable to identify familiar faces. If you show the photographs of a person who may be closely related to him, his father, brother, mother, he doesn't identify the person from the picture. But he will be able to identify the person through their voices. So that condition of inability to identify the faces is the prosopagnosia. Then we have cortical deafness. Now this will result whenever there is bilateral lesion to area number 41. So the person will have both verbal and non-verbal auditory agnosia. He doesn't understand spoken speech or even the non-spoken sound. Then we have Wernicke center here, part of it located within the temporal gyrus, that is area number 22. So if there is lesion to the Wernicke center, then that will result in sensory aphasia. As I said earlier, we will deal with this more in detail when we discuss about speech. Now coming to functional areas in insula. Insula is buried in the depth of the posterior ramus of lateral sulcus. When we discussed classification of sulci, we said that this entire lateral sulcus is a secondary sulcus formed because of the slow growth of insular cortex and faster growth of the surrounding cortices, which will grow faster and they overhang on the insular cortex. So insular cortex get buried in the depth from all around areas. The part of the parietal lobe, part of the frontal lobe, part of the temporal lobe, they grow faster and they grow over the insula. So if you want to visualize insula, you have to open up the lips of the posterior ramus of lateral sulci and go into the depth. So within that area, you are seeing firstly upper surface of the superior temporal gyrus, and more inside you are seeing the insular cortex at the top. So sulci, coming to the sulci and gyri on this insular cortex, firstly that entire insular cortex is surrounded by a circular sulcus. The apex of that circular sulcus coincides with the anterior perforated substance, which is known as, that area is known as Lyman insulae, and it represents a gyrus known as gyrus ambiens, both of which are part of the olfactory pathways. Then within this insular cortex, there is a central insular sulcus which separates this insula into a larger anterior part and a smaller posterior part. The larger anterior part is further divided by 2 or 3 sulci into multiple gyri brevis, and the larger posterior part is known as gyrus longus. Its main input, that is projection input, is from the ventral posterior nucleus of thalamus, medial geniculate body, that is auditory pathway, pulvinar and mediodorsal and intralaminar nuclei of the thalamus. Association input is from the various sensory areas, that is primary as well as secondary sensory areas, sensory association areas, that is area 5 and 7b. It also receives input from orbitofrontal cortex, olfactory areas, limbic and auditory areas. So it is receiving input from various sensory areas. So the function is Probably the anterior part is involved in taste and olfaction, and posterior part in some way is connected with somatosensory input, language function and vestibular function. Thank you very much. Hope you enjoyed this video. Please visit this site for other neuroanatomy videos. Thank you.